So this third part of the gas law, I want you to get conceptually what Dalton's law says. And again, in this introductory course, we're not going to use it to its full extent. When you take Chemistry 1, you'll get to use Dalton's law to calculate the partial pressures of a vapor over a liquid, and use Dalton's law in other ways. But I want you to understand the basic idea of what Dalton's law allows us to do. So Dalton's law says that the total pressure of a mixture of gases is equal to the sum of its partial pressures. So these right here, these pressures represent partial pressures, and this would be the pressure of the gases if they were all by themselves in the containers. And so it's kind of really a big deal, because what it's telling me is if I have several gases in the container together, that if I add up their individual pressures, that tells me the total pressure of the system. So for example, it says, the problem says a mixture contains hydrogen, so there's one gas at 325 torr. It has nitrogen, its partial pressure is 475 torr, and then oxygen at 650 torr. So there you have three gases in a mixture, and you know each of their individual pressures. And so the question is, what would be the total pressure of all these gases together? So Dalton's law allows us to figure out the total pressure by adding up the pressure of each one of the gases. So the pressure of hydrogen, the pressure of nitrogen, and the pressure of oxygen. So it'd be 325 torr. Now if they were not all in torr, you'd have to change them. They have to be in the same unit. Plus 475 torr plus 650 torr. And so if we just add up those three numbers, then we will have the total pressure in the system. And Dalton's law works quite nicely with the ideal gas law. And so what we find is that the total pressure of this system, Dalton's law allows us to calculate it, is 1,450 torr. So conceptually, I'm just really looking for you to have this idea that when you have a mixture of gases, the sum of the partial pressures would give you the total pressure of the overall mixture.